We all know that when a heated body is kept for some time, it, that body will gradually loses heat energy to the surrounding, and ultimately the temperature of the surrounding and the body will be equal. That means it attains the temperature of the surrounding. So now, to know how slow or fast a given body can cool on exchanging heat with the surrounding, we will study Newton's law of cooling. This law gives us the idea of how fast a body can release heat energy to attain the temperature of the surrounding. In thermal conduction, we have discussed that the energy flow from higher temperature area to the lower temperature area, and it depends upon the temperature difference. So it is obvious that during cooling process also, the body at higher temperature release energy to the body at or surrounding at low temperature. So now also we can say that the rate of loss of heat energy is directly proportional to the temperature difference. Okay. The nature of the surface of the body and the exposed area of the surface. So the expression will be minus dq by dt, that means rate of loss of heat with respect to time is equal to k proportionality constant T2 minus T1, where T1 is the temperature of the surrounding and T2 is the temperature of the body. Let us consider m is the mass of the body, and S is the specific heat capacity of a body. Specific heat capacity of the body. Then decrease in temperature with respect to time, that is decrease in temperature with respect to time, can be written as m as change in dt2. Okay, so it is a small amount of temperature fall. When a body loses energy, there is a loss in temperature or decrease in temperature. So for dq amount of loss of energy, we taken into account the decrease in temperature of the body. So the amount of heat loss is equal to ms dt2. Therefore rate of loss of heat dq by dt, that means with respect to time, it is ms dq, sorry, it is t2 by t. So if we number this equation as 1 and this is at 2, we have minus from 1 and 2 minus ms dt2 by dt is equal to k t2 minus t1, k t2 minus t1. So we can collect all the temperature term in one side, on one side, and another terms on the other side. So it is k by ms dt with a negative sign. So this part can be written as equal to minus capital letter K dt. So it's capital letter K is equal to K by ms. So on integrating this equation, I think all of you can integrate this equation, isn't it? So ddx of dx by x is equal to log x. So this is similar to this expression. So we can write here log t2 minus t1 is equal to minus x, integration of dt is equal to t, so minus k t with a constant c. So from experiment we can write the value of c. So the final expression will be t2 equal t1 plus c prime exponential minus kt. Okay, so c prime is equal to what? C prime is equal to exponential to the power c. So c prime is equal to exponential to the power c. So this equation enable us to calculate the time of cooling of a body through a particular range of temperature. That means what is the time taken to cool the temperature from T2 to T1. We can use this equation to find out the value.